In this lesson, we're going to find the limits of trigonometric functions. Now, these are going to be special cases. We've already talked about the fact that if you plug in an x value for a trig function and you get a number back, that's going to be the limit, right? However, if you don't get a number back, if you get an undefined, you have to resort to other methods, and that's what this is all about. This is a special case for trig functions when you don't get a number back. This is not the squeeze theorem. This is a different case entirely. So follow these steps when it doesn't take on the form of the squeeze theorem and when it's undefined. So you have evaluate the limit as x approaches pi over 4 of f of x. Now the special undefined in this case, this is going to be a whole. Why? Because if we take pi over 4 and we plug it into the bottom, we get sine of pi over 4 minus cosine of pi over 4. Well, they're both equal to square root of 2 over 2 if you know your unit circle well, which you should, right, because you're in calculus by now. You'll get 0. So in the top tangent of pi over 4 is 1, 1 minus 1 is 0, so you do get a whole, right? This is kind of like finding the limit of a rational function too, because we're going to end up canceling some things. So yeah, if you get a 0 over 0, you can use this method, and it's very similar to rational functions. Step 1 is to rewrite the function using trigonometric identities. So it's sort of like factoring, except you're going to have to use identities. Now the bottom is not an identity. There's nothing we can do with that. But if you recall when I taught you how to simplify trig functions using identities, you want to turn everything into sine and cosine. So what? Tangent needs to be rewritten as sine over cosine. But we have a minus 1 on top, and so in order to combine the top, we're going to have to write this 1 as cosine over cosine so that we can combine them with like denominators. So that's exactly what we're going to do. Now we can subtract the top. It's going to be sine minus cosine, and the bottom is just going to be cosine. Scroll down a little bit here. Now what we're going to do is we're going to take this fraction. Let's use some color here so you don't get confused, because this is a complex fraction. We're going to take the top here, and we're going to be multiplying by the reciprocal of the bottom, like so. Alright, let's see if I can make that a little bit cleaner. Nope, okay, one second. Okay, so notice what happens when you multiply by the reciprocal at the bottom. You are going to have some things cancel. So like I said, it's kind of like the rational function limits of those. So cancel those two common factors. Now you're left with 1 over cosine of x. Now it's important to note that we can cancel these assuming that x doesn't equal pi over 4. If it does, we're canceling 0 over 0, and we can't do that. However, we can cancel because and this is important. It's because we're interested in the limit as x approaches pi over 4, what it's approaching, not what the y value is. We know the y value doesn't exist because it's a whole there. But we can cancel because this will be true for any x value other than pi over 4, and that will therefore tell us what the limit is, because it's what it's approaching, not what it equals. Now we know that 1 over cosine is equal to secant. That's a reciprocal identity. So f of x is equal to secant now. And now for step 3, we can evaluate, we can plug in that x value now that we've canceled some stuff. Just to reiterate, I don't know if I mentioned step 2. Once you rewrite using trig identities, you then go ahead and you simplify for step 2, which I did by combining the top, because it was just minus 1, so I had to do cosine over cosine, and then simplifying means canceling, and now we can plug in for step 3, just reiterating that. So what is, now we're going to plug in pi over 4 to secant. Secant of pi over 4 is square root of 2. It's the reciprocal of cosine, which is square root of 2 over 2. And that's equal to 1.4 approximately. So therefore the limit of our original function is approximately equal to, and I'll just write this right here, 1.4. Okay, so here's our function f of x equals tangent of x minus 1 over sine of x minus cosine of x. We used trig identities, we simplified, we canceled common factors, and we arrived at the limit at pi over 4 is equal to approximately 1.4. Let's take a look at the graph and see if that's the case. So here's our graph. It looks a lot like a secant graph, right? I mean, it's basically secant is what we proved, except where? Except at pi over 4. And as you can see, if we zoom in, at pi over 4, we have a hole at approximately 1.4, which is square root of 2, which is what secant of pi over 4 is. So this function is basically secant of x, except for at that x value, and this is the graph that shows that limit. If you have any other questions about this, let me know.